Where she be?
Morning, all Tuesday, October 12th, 2021. Welcome back to the Maroon Day today. Lunch, pancake, sausage bite, fish and cheese, ham and cheese stuff, chicken salad, main line, Spartan grill, cheesy pizza, Hawaiian pizza. Volleyball going on this evening, 5 o'clock JV, 6 o'clock ninth grade. Varsity game scheduled for 7. All against the Bell beats the Broncos today. PSA meeting Wednesday, game room or lunch. All are welcome. Anime Club, today during lunch, Mr. Lightenberg's room. Every Monday, all anime fans are welcome. You received an email, 3.55 or higher if you're a junior or senior. Apply for National Honor Society, you run out of time to do that if you've not done so. Deadline is October 15th, that's Friday. Those of you who signed up to take the ASVAB test this afternoon, it is in the library, you must bring your computer. Church charter, so bring your cord. The testing today, you should report at 12:05. It takes place during blocks 3 and 4 this afternoon for all of you that signed up for the ASVAB. Please stand for the pledge. To the flag.
One nation, under God, indivisible, with liberty and justice for all.
All have a great day and a great week.
Are you taking this today? Bless you.
Looks like we're either done or finishing up. Last 2 or 3 working. Alright. I'm going to say, don't you start with me. Did we remember the most basic part of it? Did we remember our placeholders? Okay. There's a big difference between getting a check for $28 versus $208, right? Zeros as a placeholder matter. Long division, the way we first learned it, think back in Algebra 1, because I know you do polynomial multiplication there. Just like old school multi-digit division, x to the 4th divided by x. And you multiply. And then you change the signs. Negative 3x to the 3rd. Drop it, little hot. Negative 2x squared. Do it again. You just keep going through that pattern until you hit the end of the rainbow. Say negative 3x to the 3rd divided by x is negative 3x squared. Multiply. Minus 9x squared. Change your signs, because we're subtracting that term. This part will cancel, but this gets me a 7x squared. Drop it. It's a little hot, but it doesn't actually do anything, right? No, that's not squared. Go again. And say 7x squared divided by... Does that even count?
I don't think so.
Okay. 7x squared divided by x is 7x. 7x times the stuff is 7x squared plus 21x. Almost there. Change the signs and get negative 21x. And drop it. A little hot. And we were so close. It was almost there. We say negative 21x divided by x is negative 21, getting me negative 21x minus 63. And when we change our signs, there's still 60 left over. So what do we do with it? Over the divisor. So I'll tack on there plus 60 over x plus 3. That's a way to do it. It says by 2 different ways. So then along comes synthetic division and makes life way easier. All you take is the coefficients. You say 1, 0, negative 2, 0, negative 3. Be careful, what do I use right here as my divisor? The 0 of that factor. Okay, so I'll take negative 3 by 1, get a negative 3 and add them. Negative 3 by negative 3, get a 9 and add them. Negative 3 by 7 and add them. Negative 3 by negative 21 and add them. And because I took a quartic and divided it by a linear factor, I have a 1x to the 3rd, a negative 3x squared, a 7x, a negative 21 constant, and this guy at the end. Some books will do that. I don't know if some of you prefer that. Just like a line or a box or something at the end to separate, like this is my remainder. And plus 60 over x plus 3. So we're going to say, assuming you did this right, your work shown for this way, your work shown for that way. for both of them, the correct dividend with the correct remainder. And then the floater for, oops, 3 plus 3 is not 9. Because, so that'd be like, you're all the way back here, right here, and you said instead -7. Oops. And then it kind of dominoes the rest of it, right? So yeah, this is going to be wrong, but did you write divisor with remainder? Were your divisor and remainder correct based on your work? Okay, cool. So this is just one off for, oops, I missed a negative. Okay? Anything else? Okay. Then, before I get going, I ain't gonna put anyone on blast because there are about 5 of you. Ahem. I forget to do something sometimes. Where's your assignment? Where 2 places is that particular thing? Okay. I make a point of putting everything here for a reason. Okay. Under our page, our book, because you forget what clever is. Maybe you're on a home computer instead of on your school laptop. If you're on a home computer, that means you don't have that extension built in. Okay, you poke this and it'll still bring you to Clever and it'll have you log in. That's your single login for all your books. I don't know where the material is. Right there. And if I remember right, I think, are all the material links in Planbook toast now? Okay. So what I do every year is I copy paste over the previous semester, and then we just edit it and alter it as we go. So Google updated their terms of service, and it basically shut off all the links to my old folder because it said, hey, basically you've had these on share for 5 years. You should change that. Someone might be stealing your identity or something. I don't know. So yeah, I need to go and edit all the links in Planbook. But that's where everything is. Everything you need for the class, right there. Okay? You get your phone taken away. Mom and dad are actually parenting. There you go. Or maybe you dropped it in the toilet. I don't know. Ran it over. I found out at conferences, parents are just as bad for crap phones. I don't know how many parents set their phone on the table as we're talking, and I look at it and it's got a cracked screen. They're just as bad as kids. Playlist. Oops, I forgot to update a link. The playlist for everything we've ever done. Every class. Like that's in the settings when I set up the live stream. So there's everything. Okay. And then Planbook is embedded. Join code right there. Okay. I'm going to forget to do the stuff on Remind sometimes. Last week was a hell of a roller coaster. It was like midterm grading until 1 a.m. for a few days. Get all of that stuff in. And then conferences. And then a sinus infection on top of it. And roll right into the weekend. And we had like a big 8-hour geekathon for game club in the library. And then there's some famous magic YouTube dude who was in town. And I drove all the way to Rapid and brought him over here so he could play with us at our local game store. Like, there was a lot of stuff that happened. I forgot. Oops. I just want to make sure. Okay, y'all know where stuff is. We are about a quarter of the way, a little over a quarter of the way through the semester. We got a lot of semester to go. So I want to make sure that everyone still knows where stuff's at. Okay? Poke. Ugh. That said, I didn't receive any questions other than, do we have homework? Talk to me, Goose. Pretty much like the warm, fuzzy days of old school algebra, just move letters and numbers around. Okay. Which is good. We use that, we're going to use that synthetic division particularly pretty heavily today, the next few days. But also the long division, you got to know it. Even if you don't like it, you got to know the long division because sometimes we have to divide by a quadratic or a cubic to figure out what's left. So, cool. We know that stuff then. Game on, I think. Oh, yeah, because like 9 people are always going to ask me. Yes, old desk replaced older desk. Yay. I like this because if you wander down during Spartan time, all the geeks can still be doing their thing. And I still got room for a kid to sit on each end, and I can work with you because I read and write upside down. So, perfect. Okay. I've been tutoring one-on-one since like 4th grade, so I write upside down. Kind of freaks kids out when I turn their paper back at them and say, stop that, and then just start writing. All right, cool. So we all have graphing calculators in front of us, and yes, a lot of the stuff that we're going to do today, it's kind of a why would I do that when I can just look at the screen? Back in the ancient days, in the days of ancient magic, we didn't have a graphing calculator. So old dead dudes figured out, if I want to solve a polynomial, there's all of these possibilities, right? We know that we can do synthetic division. If it comes out as a 0, it's a factor. I win. It's a 0. But how do I know what numbers to pick is the thing when you're just starting from scratch. And if I told you right now, maybe I won the lottery over the weekend. I got $138 million sitting in my account, and I am going to give 30 grand to whichever one of you can guess the exact number that I'm thinking of right now.
12. Between what you want? 2. 135.
It's going to take forever to guess the number, right? It was 9 pi plus e. Do you really want to get... Because it's $9 and that's usually like a 20% tip or so. And when we go out to eat, I'll put that on the tip line just to piss them off. So, to make them mad. Sorry, it was a long weekend. I'm tired. I'm tired. I'm sorry. So you heard nothing. Censor that. You can't just guess and guess and guess and guess and guess. Now, most of the polynomials that we're dealing with, they got integers, right? Nice, easy numbers. Sometimes they'll have rationals, but they're nice rationals. The 0 might be 3/2. Well, that's easy enough. I can see that it's about halfway in between 1 and 2 on my screen. I could probably guess at 1.5. But what happens when it's 8/17? Are you ever going to guess that? You're going to guess and check and guess and check and guess and check and guess and check forever. So these famous old dead dudes came up with some theorems to take the infinite number of possibilities and narrow it down to maybe 16. Do we want to guess and check 16 things? No. Is it still better than infinite? Yeah. So, round one. Rational zero theorem says, stop that. Bad Frank. Says if I got a polynomial, by the way, this might look like gibberish. It is not. It is sequence notation. They're saying if I got a degree n, say like it's x to the 15th, a sub n means the coefficient in front of the 15th term. Y'all know, like, most of you are in chemistry, the subscript, it doesn't mean square the oxygen, right? It means there's two of them. So this denotes it's the nth term. So this would be like 305x to the 15th. This is the coefficient that goes in front of the 15th term. Well, n minus 1. If it's a degree 15, what's n minus 1? 14. So this says the coefficient in front of x to the 14th. And then the coefficient in front of x to the 13th. And then the coefficient in front of x to the 12th. And it all the way down here until the coefficient in front of x squared, coefficient in front of x, coefficient of, well, it's x to the 0. So it's just going to be my constant term. Okay, so that it's just a notation. It's the way to write it as a sequence that says this counts for everything, no matter what polynomial you got. Okay, it says if I got polynomial, and we'll write it in Sullivanese instead of this, where it's qx to the n plus p. Okay, you're going to have the beginning term, leading term, constant. Whatever's in between there doesn't matter. If I look at the first term and the last term, then all of my possible rational zeros are all the factors of p over all the factors of q. And that should sound familiar from Algebra 2. Okay, so if I had like 3x to the 5th plus 10, I would take all the factors of 10 over all the factors of 3. So we'd have 1, 2, 5, and 10 over 1 and 3. But then you got to list them out, right? 1 over 1, 2 over 1, 5 over 1, 10 over 1, 1 over 3, 2 over 3, 5 over 3, 10 over 3. Technically, couldn't those be positives and negatives? Now, I get lazy. I don't like to write plus minus 1/3, plus minus 2/3, plus minus 5/3, plus minus. Instead, I put plus minus and then list them, just because I don't want to. Okay, and that's it. Now, that's still a lot. That's 1, 2, 3, 4 doubled 8 plus or minus 16. That's 16 different things to guess and check. But I'd rather guess and check 16 things than 64,000. Like, you remember back to the beginning of your algebraic experience. Y'all remember when you first learned about factoring quadratics? Now, if you're in here, you were probably pretty good with your multiplication facts. How many of you had a teacher that was just like, take all the factors of A and all the factors of C, guess and check until you run into the one that foils out correctly? Okay? Someone in here's had the teacher who did that. And what happens is, what happens when Lindsay guesses it right on the second try? But then Ashlyn's back here on like the 15th try, like just screaming at her paper because nothing's working. And you look around the room and like everyone else is done because they happen to guess it correctly on the first try or the third try. It's not fair. Okay? I would rather narrow the choices down to 16 things instead of, well, just pick numbers and throw them at the wall, hope something sticks. Okay? It's called rational root theorem. So, list all the possible rational roots, determine which ones, if any, are zeros. They're going to start with baby steps. P over Q is 1 over 1. So how many possibilities are there? 2, right? Because it's plus or minus 1 over plus or minus 1. So when I say the possible, do you all remember that kind of a double blurry Q is rationals? The possible rational zeros are plus or minus 1. And it asks which, if any, are actually zeros. How do I know if they're zeros? I could plug them in manually, or we learned a faster way to do that. Remainder theorem. 1, 0, 1, 2, 1. And just try. We'll try negative 1. Negative 1 by 1 is negative 1. Negative 1 and 0 is negative 1. Negative 1 and 1 is 1. 1 plus this 3 is, oh, that's not going to work. Sad face. Negative 1 is not one of my zeros. So I try positive 1. 1 and 1 is 1. 0 plus 1 is 1. 1 plus 1 is, 1. 2 plus 1 is 3. 1 times 3 is 3. 3 plus 1 is 4. Crap stack. So what do I answer? Okay. Possible rational zeros, plus or minus 1. Actual rational zeros, there aren't any. There are no rational zeros. Meaning the only zero of this thing is going to be an irrational number, the cube root of a thing. That's okay. Even if they're not rational, they're still real. Everyone eyeballs their friend. Even if you're not rational, at least you're a real one. People have been giving me crap about Billy Joe over here for years. I'm going to say possible rational zeros, all the factors of 9. So 1 plus or minus 3 plus or minus 9 over plus or minus 1. But I can't just leave it like that. I actually got to write them out. Now in this case, it's just all that stuff over 1. Y'all cool that it's just going to be plus or minus no matter what? Because like positive 1 over positive 1, positive 1 over negative 1, negative 1 over positive 1, or negative 1 over negative 1. Right? Because it's plus or minus and plus or minus. Aren't all of these still going to come out as just plus or minus 1? Okay, so that's another reason that I think putting all those pluses and minuses is overkill. I'm instead going to write that as plus or minus this stuff over 1, this stuff over 1, this stuff over 1. Because if I just put plus or minus this stuff, it's less writing. Okay? So that's what's possible. 1, negative 1, 3, negative 3, 9, negative 9. I don't want to test 6 things. 1, 2, 3, 4, 5, 6. There we go. 1, negative 1. 3, negative 3. 9, negative 9. Go! Just test it. Do synthetic division with that number and see if it works or not. That way we don't have to do all of them. 1, 3, 5, 7. 5, no. 3, negative 3, negative 1. That was 3, 3. Negative 3 and negative 3 is 9. Hey, there we go. That's one of them. Yeah, one of them. It's not negative 9. What about positive 9? Nope. Okay, I found negative 3 worked. Negative 1 works. So we're going to get in this habit now. Remember, you can keep going. Once you find one of the zeros, you can just keep going. Say negative 1, 0, 0, negative 3, 3, skadoosh. Okay. 3 does not work. What about positive 1? Nope. In fact, I know that no others are going to work because what does this line say as a polynomial? X squared minus 3. Well, if I have x squared minus 3, square root of 3 is not a rational number. So I know that the only rational zeros were these two. And that's if you want to keep taking it all the way to the end zone. So I'd say my possible rational zeros and then my actual rational zeros are going to be negative 3 and negative 1. Okay. So there's your answer. You are going to want some work to back it up, not just, hey, I looked at my calculator screen. Because what happens when you do like the square root of 8 versus 3? Maybe on your screen they look really close to each other. I've had a lot of times where maybe there will be a polynomial that dips down like this. I'll have a lot of kids will say, oh yeah, it's 5. But then when you zoom in on it, it does this. Way in on it. And it turns out that it's two radicals that are almost right on top of each other on either side of 5. Maybe it's 5 plus or minus the square root of 2 over 10. Okay, so you got to be careful about just relying on, oh, that's what my calculator says. It's also why we learn all of these. Now, I don't feel the need to beat them to death. I'd say if we do one of them, we should be okay. All right, so list the possible rational zeros, and then go and find which ones actually are. I'd recommend you divvy it up amongst your group so that you don't all have to find them. Or if you're the cheese stands alone, maybe shout at someone near you. Ooh, no. All the factors of P over all the factors of Q. So your denominator is just plus or minus 1.
What?
All the factors of your constant over all the factors of your leading coefficient. Your leading coefficient is 1. Oh, God, no, that would be terrible. No, thanks. There you go. Split up the work. Hey, no one wants to guess and check 16 numbers.
What am I supposed to write down?
Kill him, Smalls. Okay. It's plus or minus this, plus or minus this, plus or minus, right?
Yeah.
Since it's all over just plus or minus 1,
Yeah.
then that means plus or minus this stuff is your possible rational zeros.
Yeah, that's what I wrote down.
But why'd you put them all on denominator?
No, I just did this to separate them.
Oh, your handwriting's just, okay.
I'm so
All right.
confused. I was like, what the heck?
And you gotta admit, you wrote it like right up under there.
Yeah.
I'll do 6. Yeah, 6 doesn't work.
One, four,
Negative 6 doesn't work. Okay, 10 and negative 10 don't work. Taylor did 15. You said 2 worked? Yeah, 2 was positive? Yeah. Yeah, 30 definitely is not good. Yes, it's unjust. I believe so. Because 30 is way too big. This is 15. Wait, you take it from the. No.
No, we're not going to do that. I won't do that to you. Okay, I only found 2. The other ones are actually imaginary. Okay. So we list out our possible rational zeros. It's all the factors of negative 30 over all the factors of 1. So since it's all just over 1, I just wrote it. Okay, don't have to monkey with that. And then you do synthetic division. You guess and check and guess and check and guess and check and guess and check until you find the ones that work. Another reason that I would like to continue like this as I find zeros that work is because now I'm down to x squared plus 3. It allows me to stop. How do I know there's no more rational zeros? There could have been 4 rational zeros here. How do I know I'm done? Right? Subtract 3, square root. Square root of 3 itself is an irrational number, but that's going to be the square root of a negative 3, getting imaginary numbers. So that's why I want to keep going in a chain with my synthetic division, because otherwise, what if I just did 2 and said, okay, cool, it works, and then made a new problem? Did negative 5 and said, okay, cool, it works, did a new problem. You're going to keep doing that until you run through all 16 options. Versus, I found 2 works, keep going. I found negative 5 works, keep going. Oh wait, if I take those 2 factors out, I'm left with imaginary zeros because I know quadratics, because I spent a month on it in Algebra 1 and 2.5 weeks on it in Algebra 2 because I know quadratics. Like a lot of this stuff, never. No, like legit. I'm a math teacher and I tell kids this. Unless you're going into a STEM field where you have to know the high-end mathematics to get the engineering and physics concepts of it, you're never going to use this. Basic linear algebra, statistics, understanding a graph, geometry. That's why those are the requirements to graduate. You should know basic algebra. You should know geometry, and that's it. If you know that stuff, you can go be a functional adult. I wish instead of forcing kids into Algebra 2 and PreCalc and Chem or physics, instead of forcing kids into that stuff, how about we have a media literacy class that's required? So you can sort out what's a BS meme and what's actual information. So you can not drink bleach and take horse dewormer because you're an idiot. Okay? Like, so we really want, I wish that we didn't have push everyone through this. But if you're in this class, there's one of 3 reasons. A, you rushed through too much math, you're a junior and you have to take a math, so you might as well go for it. B, you want the Regent or Opportunity Scholarship and you need your 4th year of math because it's going to get you money. C, you actually like math and you want to go into a STEM field. If it's not one of those 3 reasons, why are you here? I wouldn't do it. That's why I didn't take Spanish when I was in high school. It wasn't required to go to a 4-year college in North Dakota. Because at the time, they couldn't guarantee every school even had a 4th year or a foreign language. Because all the schools were so small. Okay? I don't think we have to.
Is there any scholarship going to PreCalc for doing 6 years of math?
That specifically, no. But the more math you take, the higher your ACT score is likely to be, which will qualify you for other scholarships. There's also a lot of colleges that will look at it specifically for entrance. Like, I want to say School of Mines, if you just straight up get a 28, you're in. Doesn't even matter what your high school looked like. Like, you could have a 2.2 GPA. You got a 28 or higher on your ACT. All right, they know stuff. Let them in. So, like, no, you won't get scholarships. That's just to get in. But anyway, there's your rational zeros. Yes. Sorry, my conversation just went. Okay, you're beating me to the punchline. You're beating me to the punchline here. All right, next one. Leading coefficient is not equal to 1. Okay, so now I have to test stuff that might not be pretty, right? My possible rational zeros. No, I'm not going to make you do all of them. God, no. Okay. No. Plus or minus all the factors of 8. I'm going to cheat and just do this again. 1, 2, 4, and 8 over plus or minus all the factors of my leading coefficient, 1 and 3. So if I write that out, that's plus or minus all this junk over 1. 1, 2, 4, and 8 over 1 are all just themselves. But then you also have all this junk over 3. 1/3, 2/3, 4/3, 8/3. And each of those is a plus or a minus. So now my possible rational roots, there's 16 of them again, but half of them are fractions. And even though you made it all the way to pre-calc, we know that kids just don't like fractions. Okay, so Anna asks, do we really have to do all of these? Now, let's say you had been in my class before, and I said, pick a number between 1 and 10. And you looked at me and said, pi, because you know that I'm going to choose something stupid like that, because you've been in my class before, right? You just guessed really well. How do I know the difference between you already know the answer or you guessed really well? I don't. So instead, when I choose what numbers to test, I'm going to gaze into my crystal ball. I'm going to commune with the spirits. And I'm going to say, I feel pretty good about 4 and -2. I'm going to try 4 and -2. I just got a feeling. I don't know, something deep inside is just calling to me. I think that 4 and -2, I just got a feeling.
I have a question.
Yes.
Couldn't you just click a table set?
But that's not going to get you down to the quadratic with the imaginary zeros later. That's why we have to go through the process, okay? But can you streamline the process by guessing really good? Okay, so I got 3, -7, -22, 8. And I'm going to guess really, really good because I got a feeling about 4. I say 3 by 4 is 12. -7, 12 is 5. 4 by 5 is 20. Add those, I get a -2. And 4 by -2 is -8. Oh, look at that, I'm so good. I'm just really good at this guessing game, right? I say, you know what? I feel really, really good about trying a -2. Just something about it speaks to me. And I got, oh, dude, it worked again. I should totally go to Deadwood this weekend. Like, I got the magic touch. Okay. Now, if I were to look at all of these nasty fractions here, and I were to gaze into my crystal ball, I would say which of those nasty fractions is somewhere between 0 and 1. 1/3. You know what? I feel really good about 1/3. I got a feeling again. How did I end up with a 3 at the end? Aren't I supposed to have a 1? Because it's the identity? Right? Because if I have 3x minus 1 to turn it into the 0 of 1/3, I divided by 3, just like when we did our synthetic division last week. I also have to divide my result by 3. So maybe I don't have to guess and check and guess and check and guess and check and guess and check. I can just guess really good. Okay? Now I still need to list out. Here's all my possible rational zeros. And then I'll say my actual rational zeros. In this case were 4, -2, and 1/3. And I gotta have the work to back it up, because they're not always going to be rational zeros. We're going to have imaginaries. We're going to have irreducible quadratics as I try to write linear factorization. And if we don't run through the process, you'll never get to those imaginaries. We can just streamline the process by guessing really, really good. I like that one. Go! Right out. Hi.
So whenever you use a fraction, you always have to divide by that again?
Yes. Just when we did our synthetic division, we had to do that.
Yeah, I just wanted to.
Because at the end of this, you should be able to take your zeros and make linear factors out of them. So like x minus 4, x plus 2. If I called it x minus 1/3, you would need a 3 out front to create the actual polynomial. But if I called it 3x minus 1, right? Like, we're going to get to that more in a minute here when we start talking about zeros versus factorization. So there's all my possible rational zeros. Take all the factors of -21 over all the factors of 3, write them out, simplify and reduce where you can. So like 3 over 3. I'm not going to write 1 again because it's already in my list. 21 over 3. I'm not going to write 7 again because it's already in my list. And then so what? 3, 3, 3, 9, negative 3, 9, negative 9. 27. That's way too big. That's way too big. 1, 3, 15. My mental mojo fails me. So I'm going to gaze into my crystal ball and say 3x to the 4th minus 18x to the 3rd plus 2x minus 21 and say, you know what? I just feel really good about trying -1.
Yeah, it doesn't. Yeah, it doesn't go.
I say -1, 3. So -3 is -21. Is 21. Is 21. Is -21. Is -19. Is what? Huh.
Did you know about that, or are you actually like surprised? Because I can't tell.
1, 2, 3, 4, 5, 6. I'll say, you know what? That looks really close to 6. I should try. Wait a second. 6 isn't on my list. So, are these rational numbers? And that's when, having done this before, we can say, you know, I gotta know. That's between 5 and 7. There's no pattern to it, and it continues. That's an irrational number. Calculate between -2 and 0. Again, it's a decimal that continues with no pattern. So, possible rational zeros, yes. Oh, do I need to go out to plus or minus 21? Did anyone bother trying those? Did you actually try them?
No, I think 21.
21 did? -21? I don't know. I'm asking you. Ew. Ew. You can see where this is going to start getting really big real quick, right? Oh, congratulations. You are the first ones to get there. All right.
Oh, don't do that. No. Wait, what is that X? That
Means you got it. And then we'll text Mama Bear right now because I'm going to forget this in another 2 minutes.
Actually, I just made brownies this
Why do we get it done?
Lucky. Every time we got brownies, I had breast Oh, yeah.
I can't guarantee you'll get them tomorrow. We're in the middle of a painting the whole house project right now. So,
Wait, did we try some?
okay. And they're not going to work, right? Because there was nothing near 2. So, it's possible that you write out your possible rational zeros and then your actual answer is no rational zeros. It's possible that you do that. Now, that's why I chose it. So we can talk about it before you run into that on your assignment? If that had happened on an assignment, what would you do? Right? Okay. So it is possible to list possible rational zeros and then none of them actually work. Okay? Do you have a little bit of work shown to say I tried it and this doesn't work? And then go and do the rest on the calculator and say no rational zeros? Yeah, perfectly fine. Okay? Solving Z Polynomial. Okay? It's a really old book. Feel free to judge them. After the first half hour, the number of video games that were sold by a company on their release date can be modeled by a polynomial.
Why didn't they just say the number instead of making an equation? Yeah, that's what I was thinking.
Because sometimes you can actually model this and use it to predict sales.
Oh, really? Gosh, Lindsay, why didn't you know that?
Maybe you use that to inform your business decisions as to whether you're going to release a sequel or not, or expansions.
That's what Call of Duty probably does.
It's not just, dude, we made money, let's do that again. Like, no, there's actual business analysis to this stuff. But pay attention to the wording, though, where G of X is number of games sold in hundreds and X is the number of hours after the release. How long did it take to sell 400 games? What number goes where? I heard 400 goes into 4 or 5 minutes, mutter, mutter.
What did I go with the G of X? Where G of X was the number of games sold.
Listen to the Hannah. Louder.
I forgot what I said.
G of X is number of games sold in hundreds. So yes, I do replace G of X, but what do I replace it with? 4. So we have 4 is 2x cubed plus 4x squared minus 2x. Well, now what? The question asks how long after the release did it sell 400 games? So I'm looking for X because X was hours, right? Okay. Now what? It's a polynomial. We solve polynomials by setting them equal to 0. It is factorable. Or you could list all the factors of -2 over all the factors of 1. Guess and check. Do you remember solving these by factoring? You already have 4 terms. So what do these two have in common? X squared, leaving x plus 2. What do these two have in common? Leaving x plus 2. What do they have in common now? Leaving a x squared minus 1. Keep going. Remember difference of squares? What factors of -1 add up to 0 because there's no middle term?
Wait, hold on. Say the question.
What factors of -1 add up to 0? Plus or minus 1? X plus 2, x minus 1, x plus 1.
I don't know if that made any sense. Like, just factoring it in order to go to zeros instead of doing the social thing.
Well, that's what we just did. We factored.
So we can't do it like this?
If it's factorable, go ahead and factor.
Okay.
I don't care how you solve. So in this case, I just end up with x is -2, -1, and 1. Alternatively, I could have been right here and try plus or minus 1, plus or minus 2 over plus or minus 1. Right? 1, 2, -1, -2. Gaze into my crystal ball and say, I'm pretty sure a -2 works. Cool. I'm pretty sure a -1 works. and say, I'm pretty sure a words. One works. Okay, so you can either factor or synthetic division. I don't care. I just need you to solve. So what's the answer? How do I answer the question? How long did it take to sell 400 games? Right? It doesn't make sense to have negative hours, specifically because it says after the first half hour is when this polynomial works. Okay? So x equals 1 hour, right? An hour after the game went live, I sold 400 games. Okay? Yeah, 400 games in 1 hour. It's clear that they don't really understand how games work. Also, this book is like 10, 12 years old. So that was also probably in the days before pre-order existed. So go for it. You got a model. Answer the question.
You guys hit a volleyball at 43%.
No, you're over there questioning the like 40 feet per second thing, right?
No, my brain is I can't read words.
Like, I want you to think about how long a second is. Stare at the clock and think 1 second. And a volleyball that is flying through the air. Do you think it could go 40 feet?
Probably not. I mean, unless you got someone like crazy.
That went about 15 feet in 1/10 of a second. Think about it. Do you think, take a breath, just in, one inhalation is about a second. Do you think the volleyball could get from me to you? That's about 30 feet.
So eventually the average person ran about 20 feet in 1.5 seconds and that a lot of
I have no idea. Okay,
my brain is broken.
so 40 feet per second is actually very reasonable.
I'll say what?
What? No. Do the math.
I'm trying to figure out words.
About 6 years ago, I did something similar, except it slipped. And I beamed Cora Tobin in the head with my marker. Oops. Like day 2 of class. So.
Aim for me next time, because then I probably be like, oh, my PreCalc teacher hit me in the head on accident. But this one about words. Oh wait, I'm
Okay. Just read the problem.
I'm not gonna factor it. I'm gonna put it.
So I replace f of t with 20. I'll put everything on one side of the bus. It is a factorable quadratic. So take out 8. 2t squared minus 5t plus 2.
That makes it a lot easier. Wait, isn't it negatives? Well, you just made it so it's positive.
I put everything on this on the left, so I had a positive instead. Well, then, if it was all on the right, wouldn't you just factor out a negative 8? So you didn't have that problem? Okay. Okay. Well, what is t again? What is f of t? Is it possible at what times did the ball reach a height of 20 that it, as time goes on, doesn't it get higher, reach the apex, and then come back down? So, is it at 20 feet in two places? Yes, it is. Specifically, this is called the vertical motion model. Okay. So yes, at a half second and 2 seconds. Is it possible for something to move an amount of distance in that 1 second, in that 2 seconds? Very much. I came this close to shooting Lars on the run on Saturday. That close, and it just like winged right behind his head. We had our big game club geekathon, and he was being dumb, so I tried to shoot him with a Nerf gun. It was like trying to hit a deer on the run. Like you were kind of prancing too, like bob and weave, bob and weave. Okay, upper and lower bound tests. Sometimes you saw what happened when we tried to do synthetic division with that 21. It was way too big, and you could tell even halfway through the problem, this is going to get gross, right? So another one of the theorems that we can use is instead of what happens if I go all the way out to plus or minus 60. I really don't want to test numbers that big or that many numbers. So you get what's called the upper and lower bound test that says, if I do this, I know that this particular number is a lower boundary. I don't need to test these at all. If I do this and I get all this thing happens, I know that's an upper boundary. All of my zeros have to be between here and here. It allows you to narrow it down. It's pretty simple. I know they have it in mathese up here. F be a polynomial function, degree n is greater than or equal to 1, real coefficients, positive leading coefficient, blah, 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 blah. If I do synthetic division and every number in the last line is alternately non-negative and non-positive, C is a lower boundary. If every number in the last line of division is non-negative, it's an upper boundary. And you say, what the? Huh? Yo. If I do synthetic division with A, and all of my answers down here are plus, minus, plus, minus, plus, minus, alternating, non-negative, non-positive, then I know this is a lower boundary. All of my zeros are above that. If I do synthetic division with B and I end up with plus, 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 then I know that that's an upper boundary. All my zeros are below that. This is just how you're going to narrow down choices.
Can it be all negative on the bottom?
No. If it was all negative on the bottom, that means you screwed something up. There was a removable factor, I think a hole. I got to double check it though. I might just be pulling that out, like, but I think that's when it's in between the two. So like you have zeros on both sides. Okay, so if they alternate, it's a lower boundary. If they are all positive, it's an upper boundary. It tells me that my zeros are between here and here, so I don't have to keep testing all the big numbers. Okay, determine an interval on which the zeros of this thing must lie. Explain your reasoning for the upper and lower boundary tests. Again, I'm telling you some stuff that might be impractical because of the advent of technology. Because what happens if you run across that one thing on an ACT, and it is the difference between you getting into the school or not. It is the difference between you getting the scholarship or not. I don't want to be the guy who just never told you. So I'm still going to tell you stuff that might not be practical, but if you got to play the game, you might as well play it well. Could I say that I'm pretty sure all my zeros are between -2 and 7? Maybe between -1 and 7? What about between -1 and 6? Okay. So I think that a reasonable interval for my zeros is -1 to 7. Because I can calculate it. So I'm going to come along and say to -11 to -44, -24. And I'm going to test -1. 2, -2, -13, 13, 15, -15, -59, 59, and that's a positive 35. Look at the signs. Positive, negative, positive, negative, positive, negative. Because I had alternating, non-negative, non-positive. Why are they using that terminology? Why are they saying non-negative and non-positive instead of just positive or negative? Loud and proud. Isn't 0 a number that is non-negative? Isn't 0 a number that is non-positive? Okay. So they use that terminology because it's possible that it went positive, 0, positive, 0, positive. Because isn't that still non-negative, non-positive, non-negative, non-positive? Okay, that's why they use that terminology. It sounds super confusing, but they use it because it's specific and it takes into account when there's a 0. Okay?
If there's a 0 where the negatives are, can it also be positive?
No, because 0 is neither positive nor negative. If you are flat broke, do you have money or are you in debt?
No.
Neither. Right? Odds are you're teaching. Oh, wait, no, that's if you're debt. No, okay. Okay, do it again and say 2, -11, 2, -44, -24. If that 7 is truly an upper boundary, what should happen right now? All positives. Okay, so I'll try 7, 2, 14, 3, 21, 23, 140, 161. Ew. 115? 7105? No, 700 And 105 is 805. There we go. 117? Well. $770 and 49 and 770 49 is 830. No, 809 or 819. I can't think now. Yes, we did. 795. Okay. But I got all positives. You're also starting to enter the realm of math where the further you go, the less you're going to see about just straight up move numbers around, find math, calculate things, and more proof. Now, that doesn't mean two-column proof. That doesn't mean flow proof. Sadly, it does mean paragraph proof. Yeah. You're going to end up with this idea of prove that this is an upper boundary. What if they showed you on an ACT which of these examples of work proves that 7 is an upper boundary of the polynomial? Huh? But if we go through this thing in class and you see something that's got a bunch of positives on it, you're like, oh, that sounds kind of familiar. I'm going to guess that one. It might be the difference between you get it and you don't. You got the money, you didn't. You got into the school and you didn't. It might be the difference. That's why I'm showing you. Do I think this is remotely practical? No, I'm going to look at my friggin' screen. It's between -1 and 7. Look at it. But is this something that I can go through real quick and then maybe if it pops up, it's the difference between you making it or not? That's why I'm showing you. Oh, yeah. Well, it depends how much money. But usually what will happen then is if you want to get into Harvard but you have a bad ACT or an SAT score, then they'll pay to cheat their way through the test to make it look like they got a good score. And then they'll also bribe the school. Rich people get whatever they want. That's just the way it works.
When I was to leave, we had this guy come to our school who used to go to Harvard, and he said that they don't care about your history. Like they're like some people like are just doing something like crazy insane and they just accept it.
It depends on what the school you want to go to.
Okay, they don't care about the test scores if they're above a certain mark. Like the difference between you got a 33 and your friend got a 34 might not be a big deal. Now they're going to look at your courses you took in high school. They're going to look at the essays that you write. They're going to look at a bunch of stuff that confirms white privilege. And they're going to just assume that you get in. Okay? Hi. Oh, okay. So if I'm going to find all real zeros in that last one, I would use 6. I assume it's 6. And make sure it works. I'm guessing -1/2. I would just do synthetic with those and show that they work. Okay. So just go ahead and cross those out. I just wanted to show you what the boundary test is. I don't think it's remotely practical, but it's one of those things that I want to show you in case it's the thing. Because you all took the pre-ACT last year. Okay? So what is it, like 60 questions, I think, for the math section? Okay. 40? What usually happens with those for the actual ACT, 90% of it is Algebra 2 and below. Actually, the bulk of it is Algebra 2. Okay? The bulk of it is Algebra 2 and below, but that 10% is an absolute grab bag of everything from PreCalc and up. And you have no idea what you're going to get. I don't want to be the guy that never showed you the thing, and that happens to be the one question that was there. Okay? Like, yeah. 18 years later, I'm still bitter about that.
It was something
Okay. All right. I forgot summation.
You say that all the time. The frat house looking symbol. Oh.
I just forgot what it was, and it's super easy. It means add up. Oh, wait, that's an N. Shove a 1 in there. Shove a 2 in there. Shove a 3 in there. A 4 in there. A 5 in there. Add them all up. It's an additive factorial. It is summation of arithmetic sequences. It's super easy to do. We're going to do it in chapter 10. Our last chapter in this class is the easiest one because it's just a bunch of formula junk. But if you don't know what it is, right? I just forgot what it was, and then we reviewed it the next week in Calc. So, yeah. And then I retook it, and then I got one wrong in the English. So, yeah, that just started like 2 years ago. Super scores. So, yep. It would have been a free ride anywhere, and then I wouldn't have been in debt. But anyway, get it. Descartes' rule of signs. There's another. You know what? Screw it. We ain't gonna get to through Descartes. We only got like 4 minutes. Okay. What? You're a bully.
I didn't do the reading.
Be like, what is it? Super Troopers. Just snap and fly across the counter. Yeah.
I think you should just snap and leave the class and make us teach ourselves.
Last time